Here's lesson 4.2a. There's actually a lot of information that falls under this idea of classifying quadrilaterals, and so I've split it into two separate lessons. We're going to do the first part today. Prior to this, you've been familiar with the idea of what different quadrilaterals are, but you may not know exactly what the definition says. So for example, in Unit 3, we were dealing with the definition of an isosceles triangle, which is that it has at least two equal sides, and we were dealing with the isosceles triangle theorem, which talked about if I have base angles, I get the sides. If I have the sides, I get the base angles. So it's very technical what exactly is the definition and what is from a related theorem or property list. So we're going to go through the definitions of our most popular quadrilaterals. A trapezoid is something you may be familiar with, and it has one pair of parallel sides. That is the definition of a trapezoid. So if in a proof I give you ABCD is a trapezoid, you get a pair of parallel sides. And if you get a pair of parallel sides, you also get those congruent and supplementary angles, particularly same side supplementary because we're talking about the inside of trapezoids, inside of polygons. Additionally, there's some terms when we talk about a trapezoid. The bases are the parallel sides. So if I just in words give you trapezoid ABCD and I tell you what the bases are, you know which sides are parallel. The legs are the non-parallel sides. And so those are just some technical terms so that we can talk fluently. A more specific kind of trapezoid, it is an isosceles trapezoid, and it should remind you of an isosceles triangle because it has one pair of parallel sides and the legs are equal. Now, once you start thinking about isosceles triangles, we're also going to bring up the fact that the base angles are equal, and the base angles are the angles formed by a leg and a base. And so if I give you an isosceles trapezoid, you get that the legs are equal, a pair of parallel sides, and you get equal base angles. So that's a lot of information just from the definition. A kite is a quadrilateral that we don't use very often, and so you may not be aware that a kite has two pair of consecutive equal sides. Consecutive means in a row. So that is the defining characteristics of a kite. Now, a parallelogram's defining characteristics is that it has two pair parallel sides. Now, there are going to be a lot of other properties that we are going to talk about with parallelogram, but according to the definition, you get two pairs parallel sides, which then in turn gives you all of those angles. Now, a rectangle is a parallelogram with, draw a new rectangle here, 4 right angles. Now notice I said parallelogram. So I'm going to get, as part of my definition, because it's a parallelogram, that those sides are parallel, and then by definition, I get 4 right angles. Notice it doesn't say anything about opposite sides being equal. We all know they are, but that's actually not part of the definition of a rectangle. It's a property of a parallelogram. So that property actually applies to more parallelograms like a rhombus. A rhombus is a parallelogram with 4 equal sides. So I've got my opposite pair parallel, and all 4 sides are equal. I know nothing about the angles in a rhombus. I just know equal sides and pairs of parallel. Now a square is the best of both of those worlds. It is a parallelogram, and it has 4 right angles and 4 equal sides. So by definition, we get all of this information, which is a pretty powerful piece of information, but it's also a very specific, lots of criteria needed to be a square. The other shapes are more general and have more latitude in what they can look like. Starting with some very basic examples. Given a trapezoid, you immediately know you have one pair of parallel sides with angle y equal 3x plus 19 and angle x equaling x plus 1. Find the measure of these two angles. I know that pictures lie, but in this case, it's pretty obvious that these are your parallel lines. And if those are your parallel lines, you know how we like to extend them out. This angle up here is 3x plus 19. This angle down here is x plus 1. Here's my transversal. Those two angles are same side interior, and knowing parallel gives me that same side interior are supplementary. So I can write the equation 3x plus 19 plus x plus 1 equals 180. So I know that 4x plus 20 is 180. 4x equals 160. X is 40. But my problem asked me for the measures of the two angles. So I'm going to go separately back to my problem, and I'm going to say that angle X is 40 plus 1, which is 41, and angle Y is 3 times 40, 120, plus 19 is 139. And if I take a quick check, those two do add up to 180. I know my problem works. If I work them out separately and then add them together and they're not 180, I know I did something wrong. Number 2 is a tricky problem. Do the following measurements make this figure a trapezoid? Well, in order to be a trapezoid, I need that the sides are parallel. If I need the sides are parallel, I prove parallel lines by getting those angle relationships. So I'm going to look for same side interior being supplementary. If they are, my lines are parallel. That I have a trapezoid. If they're not, my lines are not parallel and I do not have a trapezoid. So I'm going to mark my picture here. So NOL, start at the bottom, is 68. MNO is 111. Now notice this one. OLN. That's the trick one, is 47. And this top one is 133. Now, why is that a trick angle? At first glance, it looks like angle M and angle L are supplementary. But notice that 47 is only this bottom angle, not the whole thing. So those are not same side supplementary, nor are angle N and angle O. They do not add up to 180. So this is not a trapezoid because same side interior are not supplementary. Therefore, the lines are not parallel. And that is how we solve almost an indirect method to say that they are not parallel. And it's not a trapezoid. Now this next one is going to combine the parallel lines idea. I obviously have a parallelogram here. And I need to find the angles. The sides are easy because the sides are equal. That is a property. Now, in order to work with the angles, we need to think about our parallel lines. And if I start here with those being parallel and this being my transversal, X is a same side interior to W, and that makes X 70. If I kind of turn my head and use my red ones as my parallels, now X and Y are same side interior, with the yellow being my transversal, and that makes that 110. Turn it again. My yellows are my parallel now with the red. That makes this 70. And this demonstrates the property we're going to see tomorrow, and that opposite angles in a parallelogram are equal. Now, given that DGFE is a rhombus, immediately, definition, all the sides are the same, angle or sides are parallel. That's just what you get with the definition. Solve for x and find the remaining angle measures. Well, solving for x is easy. It's a matter of a quick equality. 2x plus 9 is equal to x plus 5. Subtract x from both sides, subtract 9, and x is negative 4. At first glance, you might think that's wrong, but when I take the negative 4 back and look at it in the context of my expressions, my sides are still positive, and so it works. If I use what I learned in the last problem, that opposite sides of the angles are equal, I will see, let's make this a little bigger, that this one has to be 35. And if I use my parallel lines and my same side interior angles, then this angle has to be 145 and this angle has to be 145. Again, you could add them all up and make sure they're 360, but that is the shortcut to finding the angle measures. Now example 5 tells me that TUVW is a kite. My sides are marked, and so two quick equations to do the side. 31 is equal to 2a minus 5. Add 5 to both sides. A is 18. Those are the top two right here. The bottom two also quickly set up into an equation. 3 times z minus 6 is equal to 72. Divide by 3. At 24, excuse me. Add 6 to both sides. Now the angles are a little bit trickier. The temptation is to say that x equals 65 and y equals 110, but that's not correct. The opposite angles here are indeed equal. So the angles that are formed by the non-equal sides are our equal angles. These that are opposite each other here are not equal. So what we're going to do to find x is we're going to use our quadrilateral sum. And we're going to add up our sides. And we're going to find out that x is 75 degrees, which should feel pretty good because the shorter side is going to need a bigger angle to come to meet at W and U than the longer sides are if you just think about how things can physically put together. Excuse me. The next example is very short. Opposite sides, parallelogram, opposite sides are equal. Set up a couple of quick equations. 2x minus 10 is equal to x plus 80. Subtract x from both sides, add 10 to both sides, and x is 90. Repeat that for y plus 20 is equal to 3y minus 4. Subtract y from both sides, add 4 to both sides, and y is 12. This lesson will continue in the next